Vectors in physics. Scalars and vectors. Representation of vectors. Component of vectors. Ry we need to calculate the magnitude of r vector. Now, as of now, we have completed 2 chapters, and from this video we'll begin with the 3rd chapter, vectors in physics. Now, there are several mathematical tools which we require in understanding physics, and vectors are perhaps the most important tool to define a physical quantity. So in this video we'll discuss the following topics. The first topic would be scalars and vectors. The next topic will be representation of vectors. And then we'll study the component of vectors. And finally, we'll take some examples based on the concept that we're going to study in this video. So let's start with the first topic of this chapter, that is scalars and vectors. So what are scalars? So scalars are numbers with units. So you can take one example like the volume of a container. Suppose the volume is 8 meter cube. So 8 is a number and this meter cube is a unit. It's a scalar quantity and it has only magnitude, no direction. Or other way around, you can take temperature. So temperature is 243 Kelvin. It's a scalar quantity. You can take distance. Suppose it is 40 meter. So this distance is a scalar quantity. Now next we have vectors. So vectors is a mathematical quantity that has both magnitude and direction. For example, you can take displacement. Displacement is a vector quantity. You can take acceleration. It's a vector quantity. Now let's move to the next topic, that is representation of vectors. So next we have a representation of vectors. So let's try to represent a vector on a 2-dimensional coordinate system. So the 2-dimensional coordinate system, this is positive x direction, this is positive y direction. Now let's take a vector. This is vector. Let's name it vector r, and we represent vector r like this. It's a bold letter r and with an arrow on it. So this is the representation of any vector. We have taken this r in this case. So this would be the representation. Now we studied that the vectors have the magnitude and direction. So what would be the magnitude of this vector r? So the length of this this arrow, this total arrow, the length of this arrow will represent the magnitude of the vector r, and we'll write that the magnitude of vector r like this. This is the way we represent the magnitude. Now next, the direction. So let this angle be theta, the angle made by the vector in the anti-clockwise direction from the positive x direction. So let this be theta. Now this theta would represent the direction, and this r will represent the magnitude, and this is the representation of vectors, this r and with the arrow on it. So next we have components of a vector. So suppose you travel from origin to this point. So this arrow will represent the displacement vector, and will represent it with r with an arrow on it. So this is the way we represent a vector. Now if you observe carefully, you can see that you travel some distance in x direction and some distance in y direction. So this would be the distance that you traveled in the x direction, and this distance you travel in the y direction. So let this be ry and let this distance be rx. Now rx and ry are the scalar component of vector r. So this is basically the component of vectors. Now let this angle be theta. This is the direction for vector r. Now suppose that the magnitude of vector r is 1.1 meter and the theta we have suppose 30 degrees, and then we need to find the scalar components rx and ry. So if you see carefully, this is a right angle triangle. This is OAB. Now rx and ry that we need to find. So rx and ry. Now from this right angle triangle we can say that sine theta, this would be equals to AB over OA. Now what is AB? AB is ry and OA. Now the magnitude of r vector is r, so this is r, and this is equals to sine theta. So from here we can write that ry is r sine theta, and similarly rx would be r cosine theta. Now we can put the values to find the components. So r we have 1.1 cosine, theta is cosine 30 degree, and this is 1.1 sine 30 degree. So this would be equals to 0.953 meter, and this would be 0.55 meter. So these are the scalar components of vector r. Now sometime in problems you'll see that you have the values of rx and ry, and you need to find the magnitude of vector r and the direction theta. So these are the values that you have to find, and these are the known quantities. Now if you consider this triangle OAB, and if you apply the Pythagoras theorem, we can write that the magnitude of r vector and its square, it is equals to rx square plus ry square, and from here the magnitude of r vector would be equals to under root rx square plus ry square. So this is a direct formula that we can use to find the answer. Now next we can find theta also. Now tangent theta from this triangle would be equals to AB over OB. Now AB we have ry and OB we have rx. So from here the theta would be equals to tangent inverse ry over rx. Now there is another method to calculate theta. Now after calculating the magnitude r, we can use that sine theta is equals to ry over r, and from here theta would be equals to sine inverse ry over r. And another way we can use the cosine here. So theta would be equals to cosine inverse rx over r. So you can use either formula, this one also, this one also, or this one also, but generally this formula is very famous to calculate theta. Now let's discuss some couple of questions based on the concept that we have studied. So this is your question, and here we are given that this horizontal distance rx is 12 meter and this angle theta is 18 degree, and we need to find the height, this ry we need to calculate, and the magnitude of r vector. These two things we need to calculate. Now we studied that tangent theta is equals to ry over rx. Now from here we can write that ry is equals to tangent theta times rx. Now rx we have 12 meter, tangent theta we have 18 degree, and this would be equals to 3.9 meter. So this would be the height. Now next, what is the length of the wire is needed to make the zip line. That is what they are asking, this the magnitude of this r vector. This is what they are asking. So this was the A part. Now in the B part, r we have under root rx square plus ry square. So under root rx we have this is 12 meter, so it's square. Ry we have just calculated 3.9 meter and it's squared, so this would be equals to 13 meter. So this would be the answer for the A part, for the B part, and this would be the answer for the A part. So this is our next example, and here we are given that the magnitude of A vector is 3.5 meter and the angle theta is 66 degrees. This is the angle made by the A vector and from the x-axis in the anti-clockwise direction. Now we need to find the components of vector A. So the x component would be ax, and this would be equals to A cosine theta, and ay, the y component, would be A sine theta. Now simply we have to put the values. This is 3.5, cosine theta is 66 degrees, and that would be equals to 1.4 meter. Now next we have A is 3.5 and this would be sine 66 degrees. So this would be equals to 3.2 meter. So this is the final answer for this question. So this is all with this video, and in the next video we'll study the addition and subtraction of vectors.